So first of all, I am very happy to be here today at ISTA conference. And yeah, I would like to say thanks for Risto, for Radoslav, and also to Alex for this introduction. I am really proud to be here today, Alex. Okay, perfect. We are going to talk during this next 25 minutes. We are going to talk about one experiment that I did during my master's degree and that I was able to reproduce in some of our clients. That is basically a way to reduce the scope of load testing analysis. And this is something that is a pain in the neck of performance test analysts that spend a lot of time to analyze their load testing results. Because as you may know, guys, when we run a load testing, we get a lot of results coming from the results of the test execution, right? Because when we are doing load testing, we are preparing a lot of virtual users to be able to send requests to our web applications, and then these requests come with a result, and these results are being stored in memory or in a file during the execution. And then after that, we can go there and investigate if we have any issues related to the performance perspective, right? But analyze this is pretty painful. So that's the why I decided to blend software testing and machine learning to try to solve this issue. And during this presentation, that's what I'm going to share with you. The results of this research and experiment, and also some tips that I got and lessons learned that I got during this experience in some of our clients. Okay. If you would like to download this deck or the source files that I'm going to show you during this presentation, please just go to this URL, juliodelima.com.br/ISTA2021/ISTA2021. So, as Alex said, I am from Brazil, and this is some of my contacts in the social media and my mail. If you would like to talk to me about this presentation or some questions that you have, please reach out to me, and I will be very happy to help you guys to solve your questions. So, as I said, we have a big problem when we are analyzing load testing results, right? And the first one is related to this picture here. You see here a graph, and this graph has two axes, right? The y-axis is related to the milliseconds. I mean, the load time that all the requests are being took when they are processed by the server, and in the x-axis you see the timeline. So during 1 hour, in this image we can see this, in 1 hour we have sent a lot of requests to the server, and then we can see in the y-axis how long it took, right, to be processed. And when I ask you guys, where are the flaws here? Maybe you can have so many hypotheses, and I will ask you to start to think about this. If someone comes to you with a picture like this, a graph like this, and ask you where are the flaws, what you are going to answer? Okay, but just start to think about this since now. About this test, it was this graph comes from a load testing that was run during 1 hour in a row. I used 50 virtual users during this test, and when the 1 hour has ended up. I got one file, a CSV file from JMeter, that is a load testing tool, a well-known very load testing tool that has more than 300,000 lines within. Analyze this, pretty painful, right? Just 2 transactions were executed. One basically was a request to access the main page of the website, and the other one that is to do the login. But as I said before, what are the flaws? This is pretty difficult to understand, right? Because this graph was dense. It's pretty difficult to understand where are the flaws. Maybe you say, oh, this is the peak. This is the blue line that are pretty high here. Oh no, this is because the timeline is pretty long. And yeah, we are going to start to think about hypotheses, but at the end, the right answer would be we need to investigate. We should investigate this, right? And when I ask you to investigate, probably you are going to say something like, I need to go to the application logs to understand what happened in the server during the load testing execution. Or maybe you say, oh, I'm going to just take the response from the server. That is exactly what JMeter will return to you, right? Or maybe you are going to say, I need to go to the infrastructure logs and understand how was the memory, how was the process time, how was the IO, and etc. Right? So we generally start to investigate these logs or these 3 sources of knowledge, right? However, for this talk, we are going to talk about just one of these 3. Okay, just about the response from the server, that is the JMeter test results. Okay, but Julio, I know that application logs and infrastructure logs would provide very insightful, very helpful information. I know that. However, this experiment using machine learning is just focusing on this one. Okay, and if you get interested about this thing that I'm going to share with you, you can explore more machine learning and load testing and start to merge application logs and infrastructure logs to this solution, and then get a most robust solution than what you are going to see now. Okay, great. Every time that I look at the results, as I said before, the results that comes from the JMeter, I see a table like this one. And generally, this is not beautiful like this one. I mean, with colors, with alignment, pretty easy to read what is in the cell, because JMeter is not that fancy tool, right? It's more archaic view, right? However, this is what I see when I am looking at the results. And this view here shows something that is different than what we saw before, right? The table can show me the data. However, 300,000 data, 300,000 records is difficult to analyze. And when I am looking to this picture here, it's impossible to read. However, one of my hypotheses would be that the issues, the flaws are related to these peaks that we see here in this picture, right? So look at this, 72 seconds on waiting for an answer. Probably this is the flaw. Or no, maybe the flaw is in the other peaks that is lower, but still being peaks. But based on my experience, sometimes the issue is not this easy to understand, to identify, right? Maybe the issues are behind this amount of, how do I say, lines here, right? It's difficult to understand. It's difficult to see where is the flaw, because the flaw is not related just to one variable, one attribute. It's not just about milliseconds. And this is the thing that is important here, guys. When we are analyzing load testing results, it's not just about one variable, but it's about many other variables. And again, I invite you to start to think about what are the other attributes, the other properties that could be involved here to identify where are the flaws. So, thinking about this difficult to understand where are the possible flaws, I started to think about a solution that maybe involves machine learning to solve this. And when I started to do that, I thought that, first of all, before to use tools to support testing, I need to think about the critical thinker that are behind the tools. You know what I mean? It's more like how Julio thinks about the flaws. It's not just about milliseconds. Oh, it's about milliseconds and latency. It's about milliseconds, latency, and it's about how much bytes I am sending and how much bytes I am receiving from the server. And I started to think about many variables. And then I understood that the way that I, human being, identify what are and what aren't flaws are a group, a analysis of a group of variables. And then I thought about 6 of them. And then I said, how can I identify the flaws since I know the 6 variables? And then I discovered, analyzing myself, that the way that I discovered that, it's because I see patterns. I see things that are common. And then I implicitly group the results in some buckets. So let's imagine that I got a result from a load test analysis, and then I start to put some records in buckets. And then these buckets have informations that are similar. So I start to look at this. Oh, this is the bucket of fast velocity to receive, to respond, and to connect. And this is the bucket of things that are taking so long to respond, but it's successful. Oh, this is the bucket that have a lot of issues and takes so long to respond and takes so long to connect. Do you know what I mean? This is what I found. And then I started to think about what are the solutions in machine learning that can reproduce this kind of thought that I, human being, are doing. And then I discovered that there is a category of machine learning algorithms that are called clustering algorithm, that does exactly what I was thinking about. It will not, how do I say, think about what are the variables, think about what are the things that I should do. It's not going to think about the analysis of the buckets. It will not work this way. It will just identify patterns and put these records in buckets. This is what this clustering algorithm does. So I created this solution. First step, pre-process the data. I need to get the data from JMeter to pre-process. That is a term used in machine learning that means to how to say, have data with more quality. So I need to handle the data. And then after that, I need to use the k-means clustering algorithm. And then after that, I need to analyze the clusters. So you need now to read clusters as the buckets that I used in my previous example, right? K-means will take the data and put in buckets. Then I, human being, will go there and analyze each of these clusters. And after that, I will be happy reducing the scope that used to be 300K records to be analyzed to just one or two buckets that has the major flaws, the most different data that was found during this analysis. And then maybe now you are like this, tell me more about it. Okay, what I did in each of these steps, pre-process data, what I did was first, JMeter, when you use JMeter, sorry, let's go back and restate this to be clear, to be clearer. You can use JMeter by record the requests between the JMeter and the proxy, or you can install a plugin called BlazeMeter in the Google Chrome and then start to record the actions that you are doing in the browser, right? When you do the second, what will happen is that JMeter or BlazeMeter will create something called transaction. And the transaction is basically a group of requests. Let's imagine that I have two requests and I have one transaction that are surrounding these two requests. When I run the test, JMeter will record the result of the request, the result of the first and the second request, and will record the result of the transaction, making my test results, creating in my test results a lot of other data that will not be useful for me, because it will be redundant. I already have the results in the result of each request. I don't need the transaction. Generally, we use the transaction just to group the requests, so it's not useful. So I remove it from the data set, from the data that I got from the load testing, all of this redundant data. So I go down from 300K to almost 200K, right? Records. Then I did another thing. I have removed all the columns that are not useful from my investigation. So I left just elapsed bytes and bytes latency and connect columns, because these are the columns that I, human being, would analyze to understand if there are, outliers when analyzing the patterns. Okay. So the third step into the first step were to normalize the data within the range of 0 to 1. And this is very important for the majority of machine learning algorithms. Okay, so I did it just to support the machine learning algorithm to find out the patterns. Second step, I had to select one algorithm that would be able to clusterize the information. So I used k-means. There are other algorithms. Maybe you can use other algorithms, and we can also discuss about this at the end of this presentation. K-means is a clustering algorithm that is, provide us testers or curious people about machine learning, the power to um, to clusterize the information that is similar. So at the very beginning, we see just blue points, but after you use k-means, k-means can identify patterns around this data and for creating the buckets that I mentioned to you guys previously. So in this case, 3 clusters were defined. Who defines how much clusters we need are ourselves. Okay, and k-means try to identify these clusters among the data. So in the third step, I empirically defined that I would like to see k-means identifying 6 clusters. And when I defined these 6 clusters, I run k-means, and k-means come with these clusters. K-means said, Julio, I find out 6 clusters. And as you can see here, this is the amount of results that I found in the first bucket, the second, the third, the fourth bucket. And then I said, oh, this is strange, because I'm seeing 800 records here, 800 observations in this bucket. Sounds strange, right? Because the others are greater than 1,000. And then I, human being, again, have decided to go in a deep analysis of the cluster number 3, because this sounds like outliers, right? Sounds like records that are similar, but it's pretty different than the others. So when I double-clicked the cluster 3, what I found was 871 records. And when I look at these records, I started to read one by one. And then I said, oh, maybe there is a more intelligent way, a smart way to do this. And then I use it mode analysis. That is from central tendency measures, right? Like mean or average and etc. So I use mode analysis in the response message column, and then look at this. I found that this cluster are grouping the higher amount of issues. So look at this, guys. This is the heart of this presentation. I was able to, using k-means, identify in one cluster the majority of issues that are in the 300K records. That's the why we were able to reduce the scope of analysis, because I reduced it from 300K to less than 1K.
Sorry, I'm still not sure about that.
Sorry, Siri was talking to me here. Okay, so I were able to identify that this cluster is the problematic cluster, and then I can look at these results, these 871 results, to understand what's going on. And then I discovered that it was a lot of failed to respond. The server was not how they say, was very requested, so he stopped to respond, right? And I was able to find out this because I used my intelligence as a human being and the intelligence of the algorithm. So remember, I asked you if maybe the 772K seconds request are the issue, right? But look at this. It's not, because the cluster, I have created this histogram using that cluster. And as you can see here, the cluster, the greater, the higher load time found in that cluster was less than 6 seconds. What it means? It means that not always the peaks represent the issues. Sometimes the issues are within the results, hidden by some patterns that just human beings can be able to identify. Smaller than you thought, isn't? Guys, I would like to thank you again and say you if you want to keep in contact, that's my contacts. And this is the URL when you can download this and the slides as well. Okay. Thank you so much.